Okay, so we have the spell work, and let's see what answers we got. So what was the answer we got for how many, I am 29 years old, then how many weeks? 1,508. And we solved that by saying that, what's the conversion factor? For every 1 year, there's how many? 52 weeks. So then if we go days, how many days is that? 10,585. Wait, let's see. We're going to take this conversion factor all the way out. We have 29 years, and in 1 year there are 365. 0.25. You want to say 0.25? 25 days. And so what's the new answer once we do that? 592.25. Okay. So now we go to hours. And if we have your 29 years, and in 1 year there's 365.25 days, and in 1 day there are 24 hours. So what did we get there?
For hours?
Yes.
254,000.
Is that what you guys got? What'd you get, Doy?
I got 254,214.
214?
Yes.
14 hours. And then we go to seconds. So we take all of this.
You skipped a minute.
Oh, minutes, sorry. I didn't have seconds on there. And what did we get for minutes? We know that in 1 hour there are 60 minutes, so we got
15,000,042,000.
And if we wanted to know how many seconds that was, we would multiply that by 60. And then we get about 912 million or something.
915,100,000.
Okay, are there any questions over that? So these are conversions. We're using factors, conversion factors. This is stoichiometry. This is what we're doing.
It seems simple.
Except for we're using the mole. Okay? So let's go to the notes. I'm going to go through the notes really fast to get to where we need to go. Everything that I go up to there is just review. So reviewing back in the day, we said this is a dozen eggs, which means there's how many eggs? 12. This is a case of soda, which means there's how many sodas? 24. This is a gross of pencils, which means there's how many pencils? 144. If this is a ream of paper,
500.
there are 500 sheets.
How do you know that?
They say it.
And if this is 6.02 times 10 to the 23rd atoms, then what is that? 1 mole. So there is our friend, the mole. So to do this stoichiometry, we have to have balanced equations. I don't know if I've told you guys, but your test is 9 to 12 questions. I can't remember right off the top of my head. It's all free response. So you'll be given a problem and you'll have to work it out, math step by step, and get me the answer. So you have to work it from writing the equation. You have to get used to from going from giving the word equation to writing that formula equation all the way to the end to solving your problem. So again, here's just a mole. If we wanted a computer to count 10 million atoms, it would take it approximately 2 billion years to count that many atoms. So lots of time. If it was counting 10 million every second, it would take 2 billion years.
And if you spend 1 mole or 1 billion a second, it takes like a certain billion.
It takes a long time. If you had a mole of 100 bills stacked on top of one another, it would go from the sun to Pluto and back 7.5 million times. So,
Why does somebody do that, man? They're just wondering.
just wondering. Huh? The notes are on, I think, yesterday.
It depends on when you put it on there. If you lay it out, it might take time.
Yeah, but you know, if you take it from here to the sun, or from the sun, it's just going to burn it up anyway. So, a mole of particles. So you can have your mole of your of whatever atom you're talking about, but then you have the mole of your, say, your compound. So here is this is a mole of moth crystals. This is a mole of water, and then we see a mole of sugar, and you can see how they have different sizes. So molecular weight is the sum of our weights, and then molar mass is our weight in grams. So it's our weight in grams per 1 mole.
We have to label our units on the test.
Oh, yeah. So if you have sodium chloride, and I said, what's the molar mass of sodium chloride? Where do we go to find that?
Sodium.
The periodic table. And we go and find sodium, and sodium's molar mass is 23, and chlorine's molar mass is 35.5. Add them together, and we should get 58.5 grams per mole. When we're talking about molar mass, we're going to the hundredths place, 2 decimal places. So please, I am talking significant figures and everything else, we're going 2 decimal places on mass. So when you're doing your homework or anything else, so say, how many decimal places do we go? I just told you. So chemical equations. At the microscopic scale, I might say, here's my equation. I have N2 plus 3 NH2 gives me 2 NH3s. So I could say for every 1 molecule of nitrogen gas, I need 3 molecules of hydrogen gas to make 2 molecules of NH3. That's at the micro level. At the macro level, I talk about moles. 1 mole of NH2 plus 1 mole of H2 gives, or 3 moles of H2 gives me 2 moles of NH3.
So it's just the same thing with different units.
Just different units. All right. I could say it's. So, are there any questions about that? So if I say, if you have 6 molecules, we're dealing with molecules and not moles. But those numbers represented in front of our equation, this number here, which is imaginary 1, this 3, and this 2, those are our conversion factors. That's what we need to do our conversion factors. And we're going to use those as moles. So why do we care about stoichiometry? So if I have a hydrocarbon, propane, if you live in the rural area, they use propane heaters to heat their houses. So this is the equation. Propane plus oxygen gets me carbon dioxide and water, which is combustion. Okay? And because of that combustion, that's where we get our heat. If we balance that equation, then for every 1 mole of propane, I need to have 5 moles of oxygen. Okay? And then that will get me 3 moles of carbon dioxide, 4 moles of water, and then my energy, the heat that I need that's coming out from that reaction. But But what if you don't have enough oxygen? What if you come to a situation and your propane tank's not getting enough oxygen in there? So what happens if you're only getting 3 moles of oxygen? What we're going to end up making is carbon monoxide. And carbon monoxide does what? It kills you, okay? So, and then if it gets even less oxygen, then what we get is we get just a buildup of carbon. We get soot building up in there, okay?
I think I prefer soot though, over carbon monoxide.
So that is what you have to think about. If you don't have enough of something, then we're going to, it can become a dangerous situation. Or if you have too much of something. If the pharmacist overdoes when he's doing the medication and he overestimates when he's making the pills and he puts too much stuff in there, then that could kill you because you've got too much in there and your body can't handle it, okay? So what we're going to do is this is what I call the mole island. You'll hear me call it the mole bridge, pay the mole toll, whatever. I know, they're so cute. So this first one here says 1 mole is equal to 22 liters at STP. This is for our gas laws, and we're just going to ignore that for right now. We don't care about gases right now. But, so sorry, he's out. Now we have 1 mole is equal to our molar mass, and we know that 1 mole is equal to our Avogadro's number, 6.02 times 10 to the 23rd particles. So the mole, so for me to go from one place to another, so if I want to go, I'm here, and I need to get to here, I have to go through the mole. All right, we're island hopping. If I want to go from here, this island, to this island, I've got to go through Mole Island. I've got to go over the mole bridge. Everything has to be over the mole. And where are we going to find our moles? Our moles are found as our coefficients in our balanced equation. Are they groundhogs? Or are they not? Are they groundhogs?
So on the test, are we gonna have to get the equation balanced and use the coefficients, or is it gonna be?
You'll have your balanced equation. Okay. Unless it's an equation where you just have to balance it. Again, what I know, what I'm given, these are word equations. We're going back to 3rd, 4th grade, wherever you have to do word equations. And you're given all this information in that word equation. And you're given your known. And we have to get from our known to our unknown. And for me to get there, I've got to visit that little island. I've got to visit the mole. Here is if you need to go back to that to look at it, it is right there. But let's visualize this reaction. If I have 2 sodiums, and for every 2 sodiums, I need 1 mole of chlorine to get 2 sodium chlorides. That's our balanced equation. So if I gave you 10 moles of sodium and 5 moles of chlorine, then how many moles of sodium chloride can we make? We can make 10. Okay, by looking at those ratios, by looking at the numbers that are right here in the equation. So you see, we have 2 sodiums, it sees these 2 chlorines, and then we get a sodium chloride and a sodium chloride. This is another one showing you how different ways we can look at this, different numbers of looking at it. But here we go here. If I have 5 eggs, so here's our cookie recipe for chocolate chip cookies. If I have 5 eggs, how many cookies can I make? I know that 2 eggs gets me 5 dozen cookies. So if I have 5 eggs, This is my unknown. This is the coefficient of my unknown. That's the number in front of my unknown, which is my cookies. And if I have 2 eggs, it wants to know how many cookies can I get. So 5 times 5 is what? 25. And then I'm going to, so that's 25 divided by 2, which gets me 12.5 dozen cookies.
But you can't have 0.5, so it's just 12 dozen.
Yeah, you can.
Why can't I have 12.5?
That's like saying, that's
Because
like with
if
humans.
you make it individually, you need 2 more eggs, so you need 6 to make. You can't just use half.
I can take 1 egg and I can have everything else.
Also, that doesn't realistically make 5 dozen cookies.
Just,
I'm going.
Depends on how big the cookies are.
yeah.
So this is what we're doing. This is what this whole lesson is going, or this whole unit is going to be about. So stoichiometry is the relationship between our mass and our ratio. So if I say go to your stoic numbers, then when I say go to the stoichiometry, I mean go to this 2, go to this 1, go to this 2. When I say you need to use your stoic numbers to figure this out, that means you have to use the coefficients. Okay? So I can look at this, and for every 2 magnesiums, how many oxygens do I need? For every 2 magnesiums, how many oxygens do I need? What's this number in front? What's the stoic number in front? 1. If I gave you 5 magnesiums, then how many oxygens would we need?
3.
2.5? Half of 5 is 2.5. If I said, go make 10 moles of magnesium oxide, then how many moles of magnesium are you going to need? 10. And how many moles of oxygen are you going to need? 5. Okay? So this is all about the ratio. What you need to know is when we're talking about our ratios, when we're doing these problems, always, always put your unknown, when you do your conversion factor, your unknown coefficient goes over your known coefficient. Always, always. If there's nothing you get out today, then that better be the only thing that you get out today, that you have to do unknown coefficient over the known. Everybody good with that? Okay. So the next slide talks about mole ratios. So what is the ratio of something to something? What's the ratio of Al2O3 to O2? What's the ratio of this to this? 2 to 3. So now what I can do is I can write that. Remember, these are conversion factors, so I can say 2 over my 3 O2. Or we can say 3 moles of O2 over the 2 moles of Al2O3. Depending on what is given and what is unknown, you can flip your conversion factor. So what's the conversion, what's the ratio of aluminum to oxygen? 4 to 3. Okay? 4 to 3. For every 4 aluminums I should get 3 oxygens. Or we can have 3 over 4, depending on where we're going with this. Okay, so this next problem that I have here, I'm just going to kind of skip that. I have a little setup here, step by step. telling you what you need to do. So if you need to go and when you're working these problems out, then it is there for you to look at. The only thing I want to do is right now is we are eliminating some steps. So we're going to eliminate this step here and this step here for today. So the very first step is to balance your chemical equation. So is our chemical equation balanced? The one that you are given. We have CO2 plus 2LiOH gives me Li2CO3 plus H2O. So it is balanced. So the next thing says identify your unknown and your given. So I go to my problem. How many moles of water are produced if 34 moles of carbon dioxide are reacted? So what is my unknown? What am I trying to find? Moles of water. So that is my question mark. I'm going to write a question mark underneath H2O. So I know that's where I'm going. What do we know? What are we given? I am given 34 moles of carbon dioxide. So underneath, I'm going to write 34 moles under carbon dioxide. Now I can look at my balanced equation and everything else right now in this problem that we are working, I don't care about those other things. I care about the two things that I have my information written under. Everything else doesn't matter. So the very first thing says to change your given to moles. Well, we're already in moles, so we're just going to go ahead and we're going to write our given here. 34 moles of carbon dioxide. Step 4. Write the balanced equation coefficient ratio. Unknown over your known. So what is the coefficient in front of our unknown? So it is 1 mole of H2O. And for every 1 mole of H2O, where are we going with this? We're going to our given, which is here. What's the number in front of CO2? 1. So 1 mole of CO2. And now we're ready to solve. So how do you solve these problems? I take everything on top, so 34 and times 1, and I put everything on bottom that I'm doing, and then I do the math. 34 times 1 is 34, divided by 1 is 34. So we get how many? 34 what? 34 moles of H2O. You give me 34 and only 34, you're going to get points off. You give me 34 moles, you're going to get points off. You have to give me 34 moles H2O. Because if you say 34 mole, it's like me going and saying, hey Luke, go to the store and get me a dozen. And then Luke's going to go to the store, and he's going to come back, and he's going to give me a dozen eggs. And I'm going to say, why did you bring me a dozen eggs? I meant a dozen cookies. And he's going to be like, well, you didn't say it. You just said a dozen. I don't know what you mean. Okay? So you've got to put that information there, or you're going to get points off. So this one's pretty easy because we used a 1-to-1 ratio, but let's go where we're not using a 1-to-1 ratio. So, how many moles of KClO3 must decompose in order to produce 9 moles of oxygen gas? This is like you're going to see on your homework. You have got to write the equation, you got to balance it, and then you've got to do everything from there. So first of all,
Is it just 27?
how many moles of KClO3 must decompose? So my balanced equation is going to be KClO3. And it's decomposing. What's it decomposing into? I know oxygen and KCl. So we go back and balance it. How do we balance it? 2, 3, and 2. Step 2 says go identify your known and your unknown from your problem. So what is my unknown? Where am I trying to go? KClO3. And what do I know? I know that I have 9 moles of oxygen. So everything else doesn't matter. Just got those 2 I'm focusing on. So we write down what we know. We have 9 moles of O2. The next thing is we need the stoichiometric numbers. So we have our unknown on top. So what's the number in front of our unknown? 2 moles of KClO3. And that's going to be over our known. So how much, what is our known? The number in front of our known is 3 moles of O2. So now what we're going to do is we're going to multiply everything on top. So 9 times 2. So I kind of write this out here. 9 times 2 over 3. And that gets me 6. What's my units? Moles of what? KClO3. Questions? We're going to go to a point where we do not have this here. We're just going to work without that. All right. So 2 more and then we're done. How many moles of water are produced with 16 moles of oxygen are reacted? So we've got our balanced equation, and now we just have to do is identify our known and our unknown. So our unknown, moles of water. So I'm going to put a question mark under moles of water. And I have 16 moles of O2. So I'm going to put a 16 moles there. Everything else does not matter right now. So write what we know. What are we given? We're given 16 moles of O2. The next thing we need is our conversion factor. Our conversion factor to moles goes to the coefficients. So what's the our given is on bottom and our unknown is on top. So what's the coefficient in front of our unknown? 6 moles of H2O for every 5 moles of O2. Our moles will divide each other, our moles of O2 will divide each other out. And now we're ready to multiply everything on top. So 16 times 6. Multiply everything on bottom, and all we have is a 5. And do the math, and what do you get? I should see people punching numbers in.
96.
What? 19.2?
19.2? That's what I think I'm getting.
19.2? Thank you. 19.2. And my unit is? Moles of H2O. We're using the same equation from up above, so I'm going to go back and I'm going to erase my X's over here and my information up here so that I don't get confused. How many moles of oxygen? So that means now my oxygen is my unknown. Are needed to react with 24 moles of ammonia. So I have 24 moles of ammonia. So where do I start? What we know, 24 moles of NH3. And we need our conversion factor. So, what is we need our unknown on top. What is the number in front of our unknown? 5 moles of O2 over 6, or 4 moles of NH3. And now we're ready to multiply and divide everything out. 24 times 5 over 4. 30? 30 what? 30 moles of oxygen. So what we're doing today is going to be used in every way throughout this unit. Okay? So for me to get from NH3 to O2, I have to use this ratio. I have to use those stoic numbers. Okay, so let's go to your homework. Take your homework out and go to question number 1. And question number 1 states, so mole ratios and molar masses conversion factors. You need to answer, since you're going to have to show your work, you're going to have to answer these on your own sheet of paper. So number 1 says a blank ratio. So what's in the blank? Mole ratio. A mole ratio is a what factor? Conversion factor. That relates the amounts of moles in any two substances involved in a chemical reaction. So if you go to the chemical reaction they've given us, I've left out the 2 in front of H2. So put a 2 in front of H2 so that you get a balanced equation. So put a 2 in front of H2 to get a balanced equation. So we have, for number 1, we should have 2H2 2H2 plus O2 gives me 2H2O. And then the next thing just says, what's the mole ratios? So you can give me different mole ratios. Give me at least 3 mole ratios. For every 2H2O, you need 1 O2. I don't care what you do. Just give me some ratios. Then the next question, number 2, what I'm going to work for you. And the combustion of methane gas. So methane is CH4. It's combustion, so what's it react with? O2. And it produces what 2 things? Carbon dioxide and water. So we've written the equation. Now we need to balance it. So how do we balance it? I'm going to put a 2 here and a 2 here. So 1, 2, 1, 2. So step 1. Step 2 says we need to identify our knowns and our unknowns. So how many moles of water vapor? So I need to put a question mark underneath water. That's my question mark. Are produced under the combustion of 4 moles of methane. So I have that. Everything else I can ignore. Start with what you're given. We are given. So I go up here and I say, oh, we're given the one that has the number with it. 4 moles of CH4. I need to get to moles of water. So that means I need the stoic. I need the numbers in front of my known and my unknown. So my unknown goes on top. So what's the stoic in front of our unknown? 2 moles of H2O. What's the stoic in front of our known? 1 mole of CH4. We are in moles of H2O. My question says to get moles of H2O. So we are good, ready to solve. So 4 times 2 over 1 gets me 8. What?
Moles of water vapor.
Moles of H2O. So, with that being said, I do have a worksheet up here. This is optional practice for you. That is over mole ratios. It gives you the equations. You go and balance them, and then you go and answer the questions to figure out how many moles are going to be produced. So if you want one, then you're more than welcome to grab one and take it. Any questions?